Hello guys, welcome to our channel berb3. So in this channel we'll be teaching topics like system design, database concepts, say front end, back end, along with other coding questions as well. So today we'll start our discussion with a DB architecture, that is master-slave architecture. Okay, it's one of the main designs that we follow for improving performance of the application. So let's get started. So as per the name, it suggests that there's a master and there is a slave. So who's a master and who is slave here?
Hey, no matter what they do, it's the master of blaster.
So in the case of database, we'll be having multiple databases here, okay, DB servers, and one of them will act as a master database on which the update, insertion as well as deletion operations will be happening, and the data will get replicated into the slave DBs. Okay, so the design will be something like this. There will be a master database, and there will be multiple slaves. Slave DB1, let's say, and there will be a slave DB2. Now what happens is that when an HTTP request comes, okay, and let's say it is either put, patch, delete or post, okay. So let's say an HTTP request came, it is either of put, patch, delete or post. Basically these are basically update in DB, update, create or delete. If any of these three operations happen, then these three requests will be coming directly to the master database and they will affect directly the master database, master DB. Now what will happen after that is that the data will get changed in the master DB, and then simultaneously it will get replicated in the slave DBs. Here the replication process will happen in due course of time, right? Now what happens here is that now the write to read ratio, when HTTP requests come, so the ratio is something like this. Write operation means mostly update, create and delete, and read operations are get requests basically. So now generally it has been seen, and mostly it is that write to read operations are in the ratio of 1:10. So to improve the performance of the application, if we can improve this performance of this read requests, then we can improve the overall performance of the application, correct? So what it does is that once only we are updating, the data gets replicated here, and the next, when the data is getting fetched for the read request, the read requests are coming to these DBs. What does this mean? This means basically HTTP get requests basically. Okay. So how does this improve performance, right? Now what happens in case the master DB fails in some kind of failure scenario? What will happen? In that case, any one of this slave DBs will be chosen as the master DB by some calculations or hash functions, you can say, and this will replace this master DB. Now this master DB will go for the failure scenario and issues will be resolved in due course of time, and it will then come in the case of this slave DB, right? So now again suppose again this one failed, so it's not sure that master DB which was earlier master DB, it will become again the master DB. It will again be pre-processed and one of them will be selected. by some function. Okay, so this is how this master-slave architecture works, right? Now this improves the performance. In how does it improve the performance? One way is high availability, right? Data loss is not there. Suppose this one failed, but the data has been already replicated here, so data loss is not there, right? So in this way, you can say the performance got increased properly, right? So that's about this master-slave architecture overall. If you want to increase further, you can add caching, load balancing, all those things are there. We can discuss these topics later in the due course. Thanks a lot.
तो जरा सबर करो, the video is not completed yet. If you like the video, please like, share and subscribe.